Parallel and perpendicular lines. So, when we're graphing vertical lines, our equation looks like x equals some number. X equals some number. So, for example, x equals, Jacob, give me a number.
5.
You're not.
2. 2's a good number. So x equals 2. So to graph x equals 2, I want everyone to sketch an x and y axis. What we're going to do is we're going to go to +2. And we're going to graph a vertical line. Beautiful. So our slope is undefined. Exactly. Our slope is undefined. Sure. You could abbreviate it. All right, let's do another example. What if, let's see, I'm going to scoot this up a bit if y'all don't mind. Do I need to pause?
Yes.
Okay. So let's do another example. Let's say x, oh, I need my pen. X equals, Ms. Laura, can you give me a negative number? Ooh, -5, nice. That's a beautiful number. -5. So, to graph x equals -5, so I want everyone to sketch an x and a y axis. Beautiful.
Is there a way you can do this on the calculator?
You could do this on the calculator. Remember earlier this week when we were graphing relations? So if you graph the relation x equals -5, it will graph a vertical line at -5 for you. Do it. So I'm going to go to -5, so 1, 2, 3, 4, 5. And I'm going to graph. There we go. A vertical line at -5.
5 is honestly my favorite
How
number.
come on here?
5's a good number.
I don't know why actually.
What's that? Oh, because you did f of x, so go tab. You guys, so a vertical line is parallel to which axis? The y-axis. It crosses the x-axis parallel to the y-axis. So I'm going to make a note of that. So, hold on, let me see if I can. So I'm going to say crosses the x-axis is parallel to the y-axis. Yes, it's a line.
It's parallel.
Yes. All right.
In some other units of math, isn't that like not a line?
I think you're thinking of geometry. We'll get to that next year. All right, let's take a look at horizontal lines. Horizontal lines, the equation looks like y equals some number. So it's just a number. There's no variables. Y is the only variable.
Can I say 2 numbers?
Sure.
5.
So for our first example, 5 is equal to 2. 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 5 we can graph y is equal to positive 5. You want to choose the next one? I'll let you choose the next one. All right, so to graph this, so let's sketch a graph. I need a y-axis and an x-axis.
This slope is 0.
Mm-hmm. Then I'm going to go through the y-axis at positive 5, so I'm going to go up to 5. 1, 2, 3, 4, 5. I'm going to graph a horizontal line whose slope is 0. Can I move that up a bit? All right. Let's do another one. Let's do y is equal to what do you think, Alberto? Can you give me a negative number? -4. Nice choice. -4 is a very nice number. So let's draw some axes. X and y. All right, so to graph this, I'm going to go to -4. 1, 2, 3, 4 on the y-axis. And I'm going to graph a horizontal line straight across.
Is this on this thing?
No, I'm going to add to it in just a moment. This is like the introduction to today. No worries, I won't bore you the whole class period. Oh, good. All right. So, like we did with the vertical lines, you guys, let's see if we can identify some characteristics of a horizontal line. So, which axis does it cross through?
Y.
Perfect. Crosses the y-axis.
Parallel to the X.
Ooh, do y'all know the symbol for parallel so I don't have to write out the whole word?
Tonight.
The two lines like that? Parallel,
Looks like 11.
doesn't it?
11 to the X-axis.
No, parallel to the x-axis.
That's what it looks like saying. It looks like saying 11 to the X-axis.
I think maybe
It
if
is
you
a
draw
symbol.
maybe if you draw them the other way.
That'd be an equal sign.
Nope, I'm trying to tell you guys. That's an actual abbreviation in mathematics. It's called two parallel lines for parallel.
If I created a symbol, I would make it to parallel.
You guys can write out parallel if you would like. I'm trying to tell you. This is the symbol for parallel.
I would
You are welcome to write it out if you would like. This is the symbol for parallel.
I would add a P in the middle.
This is the symbol for parallel.
So it was a nice way.
No, it's parallel. Shh. All right. So, we've talked about lines that are parallel to the x-axis. We've talked about lines that are parallel to the y-axis. Right? So let's talk a little more about parallel. I see a few pencils still moving, so I'm gonna wait just a moment.
Well, I don't have a pencil alive.
All right. Oh, I'm sorry. Do I need to go back? I'm done. You're done? Okay, good. All right. So, oh, hold on. All right. So, a couple of things about parallel and perpendicular. Parallel lines have the same slope. Parallel lines have the same slope. So, for example, when I graph parallel lines, so I'm going to graph a pair of parallel lines. Yes, it's just a sketch.
We draw this.
Yes, it's just a sketch. So when you graph parallel lines, they never touch, right?
Nope.
That's the special thing about parallel lines. They never touch.
Can I use my grid paper to
Nicely done.
to make sure they're parallel?
That's a good idea. All right. So for example, two lines that are parallel. I'm going to call this line A. Let's say line A is y equals, I don't know,
5.
negative 5x plus 2. And line B, let's say line B is y plus 9 equals negative 5x minus 1. Here, from my equations, I can tell that these two lines are parallel because they have the same slope. Yes? Is that okay? All right. Perpendicular lines are where it gets interesting.
Sounds hard.
No. It's just interesting. So perpendicular lines have opposite reciprocal slopes.
So what do you actually?
Here, I'll zoom in. Is that better? Perpendicular lines have opposite reciprocal slopes. And I'm going to talk right now about what I mean by opposite reciprocal slopes. Okay?
Isn't that like where we're supposed to flip it, like the other way?
Some of us are remembering our fraction vocabulary. Beautiful. So perpendicular lines have opposite reciprocal slopes. All right. So for example, if I graphed some perpendicular lines, right?
Does that mean if one has a slope of 0 and the
Oh.
other one has a slope of undefined?
Yes, so you could have one with a slope of 0 and one with a slope of undefined, right? Because the x-axis and the y-axis are perpendicular, right? So if you have something parallel to the x-axis and something parallel to the y-axis, then those two lines would also be perpendicular, right?
Yeah.
All right, well, let's do one that's not horizontal or vertical. So let's say I have this line here. What kind of slope is that? Is it positive, negative, 0, undefined?
Positive.
Positive. All right, I'm going to draw a line that's perpendicular. You ready?
Yeah.
All right. So if it's perpendicular, I know that it forms a right angle, right? What kind of slope does that new line have?
The same as that one?
Positive.
This one here?
Negative.
That's a negative slope, right?
That's what I meant.
So that's where I get that opposite from. So if one slope's positive, the other slope has to be negative. All right? And then reciprocal, we said it just a second ago. What's a reciprocal? You flip it. So an opposite reciprocal, flip and switch. That's my catchphrase for opposite reciprocal. You flip and switch. So for example, let's see. Let's say line A is y minus 6 equals, I don't know, what's a good slope? 8? Ooh, 3 over 2 is a good one. Let's use 8. We'll do 3 over 2 again here in a second. 8 times x minus 4.
Next 25.
hold on, because we want it to be perpendicular, right? So let's say my y equals, so I need an opposite reciprocal to this 8. So what's the opposite of positive 8? Negative, right? So I'm going to have negative. And what's the reciprocal of 8? 1/8. Times, oh, wait. X, I don't know, plus 9. It doesn't matter what our y-intercept is, we're just looking at those slopes, right? So if your slopes are opposite reciprocals, like 8 and negative 1/8, then your lines are perpendicular. Is that okay?
Yeah.
So, because I liked your example, Emmanuel. What if my slope were 3/2? What would be the slope of the perpendicular line? Remember, we flip it and switch it. Say it again. 2/3. So we flipped it, and what about that sign? It's got to be negative. So if your slope is 3/2, the slope of the perpendicular line would be negative 2/3. That's it. Is that okay? All right. So let's use what we've done today with what we did last week and bring it all together. You ready? All right. So I know this example is kind of wordy, so if you need to abbreviate, you're welcome to. Do I need to zoom in some?
Do you want to shred that for me?
You can abbreviate if you would like. So we're going to write the equation in slope-intercept form of the line that passes through the point -4,3 and is parallel to y equals 1/2 x plus 7. Let's see here. I'm going to figure this out so that everyone can see this. There we go. Is that a little better?
Yeah.
I'm trying to zoom in on my iPad and on my projector both so that everyone can see everything. If I zoom in too much, you can't see it on the video. If I zoom in too little, y'all can't see it at all. It's too little on the projector. All right, so to write this equation, well, I've got a point, right? I'm given this point here, -4,3. Oh, I need my pen, not my... -4,3. And then I'm given the line that my new line is parallel to. So what do I know my slope is? It's 1/2. It's going to be whatever the slope of this line is, right? Because if the lines are parallel, what do I know about their slopes? What do I know about the slopes of parallel lines? They're the same. So my slope is 1/2. And I have the point -4,3. So I'm going to use the point slope formula. Point slope formula.
That's the Y1, right?
The y minus y1 equals m times x minus x1. All right. So I have y minus, what's y1? 3, beautiful, equals, what's my m? 1/2 times x minus, what's x1?
4, -4.
-4. Oh, so it's going to be +4. Very nice. Very good. All right. So to write this in slope-intercept form, what I've got to do is solve for y, right? So I'm going to solve for y. So I'm going to distribute my 1/2. So I have 1/2 x. And 1/2 times 4 is 2, right? Equals y minus 3. So then I'm going to add 3 to both sides. So now I have y equals 1/2 x plus 5. That's it.
Hey, 5 is in the answer.
Is that okay? It's not so bad, no? All right, let's try one more. With a 7? Trying to think, well, 7's my original y-intercept, isn't it? Right there. Yes, go quickly. All right, let's take a look at example 2. So earlier, I overheard someone, it goes up there at that table. Was it you, Sophia? It said, hey, wait a minute, example 1 and example 2 are exactly the same, Ms. Reynolds, you made a mistake. Did I? What's the difference? I asked for the perpendicular line, right? I asked for the perpendicular line. So example 2 says, write an equation in slope-intercept form of the line that passes through the point -4, 3, and is perpendicular to y equals 1/2 x plus 7. All right, so I know my point is -4, 3. My slope is the opposite reciprocal of the slope of the line that's given, right? So my slope is going to be, well, this slope is positive 1/2. So if I'm going to flip it and switch it, if I want the opposite reciprocal, right? Well, this is a positive 1/2, so I know my slope's going to be negative. And what's the reciprocal of 1/2? 2. 2 over 1, or 2. Perfect. So now I can use that point slope formula. So y minus y1 equals m times x minus x1. I'm going to plug in my x, my y, and my m. So I'm going to have y minus, what's y1? 3 equals, m is -2 times x minus a -4. What did we say about that minus a negative in the last problem? It's a positive, right? All right, so then I'm going to distribute. So -2 times x is -2x. -2 times +4? -8, right? We're multiplying. Multiply. All right, so now I've got y minus 3 equals -2x minus 8. All right, so I'm going to add 3 to both sides. So I've got y equals -2x minus 5.